Today we will see sharpening spatial filters in digital image processing. First, let us see why sharpening. We already see why smoothing filters. Smoothing filters are used to remove the noise and blur the image, whereas shortening filters do the exactly opposite to it. It will enhance the images, highlight transitions between different regions, make fine details more visible, prepare for segmentation and object detection. And before moving to the directly filters, we need to know some concepts here. First one is first order derivative. It basically measures the rate of change in the pixel values. In horizontal, df by dx equal to f of x plus 1 comma y minus f of x comma y. In vertical direction, df by dy equal to f of x comma y plus 1 minus f of x comma y. It detects the edges and outlines, produces thick edges. And second one is second order derivative. It is d square f by dx square equal to f of x plus 1 comma y plus f of x minus 1 comma y minus 2 of x comma f of x comma y. D square f by dy square equal to f of x comma y plus 1 plus f of x comma y minus 1 minus 2 f of x comma y. It detects fine edges and gives thin edge lines. Why we need to know the derivative means in Laplacian filter we will use the second order derivative only. Laplacian filter, the Laplacian is a popular shortening filter. Basically it uses the second order derivative to detect edges in all directions. And mask for this Laplacian filter is in 4 neighborhood we can use these two masks here. In 8 neighborhood we can use these two masks. And Laplacian filter highlights the rapid changes in intensity. The formula for it is d square f by dx square plus d square f by dy square. We have already seen the second order derivative for in horizontal and vertical directions. So if we substitute those values here, we will get the final formula is f of x plus 1 comma y plus f of x minus 1 comma y plus f of x comma y plus 1 plus f of x comma y minus 1 minus 4 f of x comma y. And we have another filter within the Laplacian filter only. It is called enhanced Laplacian filter mask. Only the difference is here in 4 neighbor the center value is 4. Here in 4 neighbor the center value is 5. In 8 neighbor the center value is 8. In 8 neighbor the center value is 9. Basically adding 1 or subtracting 1. Here if you see here we will basically it will do minus 5 in enhanced, minus 9 in enhanced. And uses of these sharpening filters are enhancing boundaries, highlighting edges before segmentation, improving visual quality, used in OCR, satellite imaging and medical imaging. And now we will see the problem. Apply Laplacian filter on the given image on the center pixel. So this is the given image and this is the mask we are using. We can use any mask, we can use -8 or this one. So 8 into 0 plus 5 into 1 plus 4 into 0 plus 0 into 1 plus 6 into -4 plus 2 into 1 plus 1 into 0 plus 3 into 1 plus 7 into 0. So we got, if you calculate this, we got the value -14. Now we will replace the center pixel 6 with the -14. That will become our output image. And second question is, apply enhanced Laplacian filter on the given image on the center pixel. Again same process, but instead of -8 or -4, we will do -5 or -9 here. So 8 into 1 plus 5 into 1 plus 4 into 1 plus 0 into 1 plus 6 into -9 plus 2 into 1 plus 1 into 1 plus 3 into 1 plus 7 into 1. It will give, if we calculate, it will give -24. So now we will replace the 6 with -24. An important point to note here is, if we see in about 2 questions, we are taking 3 cross 3 matrices as input images. For example, if they give the matrices like this, if they give the input image like this, it is 4 cross 4. So how we will calculate here is, we will convert this input image to like this. How we will convert means, beside of 8, right, in left side upper side, we will make the all values. First we will write above this line, we will write all the values 8543, 8543, and left side also 8012, and below also 2567. Here also 7413. And corners also we will add the whatever value here, we will add those value into 8, 3, 7. So we will get this image. Now what we will do is, we will take first 3 cross 3 and then we will take this 3 cross 3. This one we will take. And now this one we will take. So if we take first one right and calculate this same process, we got one value. Then we will replace that value with this 8. And again, if we calculate second one, we got one value. We will replace this with 5. And same process we will do for, then we will calculate for all the same things. If we first row is done, now we will do this one. So like this, we will calculate the images except 3 cross 3. So this is all the about sharpening filters.